second full fork video. I know other ones have been like a minute or so, but this fully explains what's happening on the forks and inside the computer when the forks are being moved and manipulated as the manipulator. So these are the forks. They're I'm not sure what you technically would call it, but they're bent tubing. They're controlled by one window motor, I believe that is. I'm not sure. I'm the programmer. I don't build the thing. There's an encoder, and there's two buttons on the forks that control, or not control, they detect whether the ball is on the forks or, just bouncing around on the forks. That's very helpful. Forks are controlled by PID loop, which is probably the motor you can hear right now. If you can hear anything at all, I'm not sure. But the forks are going to stay in this position, even if they get tousled around or kicked around by a robot. Like I can put, that's almost my full weight in there, and the forks haven't moved at all. So let me go put the forks down to show you what happens. So right now the forks are in the down position, even though they're a few inches off the ground. That just means I have an encoder offset. But forks are in the down position. Same thing that happens as they were up there. I can't move them at all. They'll stay there forever until I tell them not to. Right here the buttons are used. Either of the buttons is pushed, it goes up to a home position, or not a home position, a settling position like this. There's one button, and until it gets input from the ball, which through the buttons, it will not move anywhere else. So I can press one button here all day, nothing will happen. If I press both buttons, nothing happens. Want to know why? Because the launcher is not armed. I've added that as a safety mechanism so that if the launcher is not armed, I don't want to kill the ball. Safety reasons from my own perspective, because I only have one ball to play with right now. So if the launcher is not armed, the force will not move up. But if there's a user cancellation on the joystick, the force will then move. So let me cancel that and then put a ball in. So it's the same thing that happens, exactly as I did before. Forks moved up, they collected the ball, and they're waiting for the ball to, or the launcher to be armed. As you can see, they're doing quite a good job of holding the ball there. The way the PID loop works is that I could add 50 billion pounds there, well, not 50 billion, more like, I don't know, 150 pounds there. And as long as the hardware doesn't fail, the programming will allow the ball to, or the forks to be at that position no matter how much force is pressed in the opposing position, or direction, rather. So, I'm going to go lower the launcher, which you're going to see go here. It's going to go all the way down until it hits a limit switch there. What's going to happen next is that the ball is obviously pressing both of the buttons. It's not tossing around. And due to that, it's going to raise the forks up, it's going to hug the ball, and then I'll explain some more then. Launcher's going back. I know many of you have asked why it's being, how we're releasing it so darn fast. That's because instead of holding it in position using the motors, we actually have two electromagnetic clutches holding it there, and then we just turn them off, like they're hooked to relays. So now we've got the forks hugging the ball. They're hugging it quite tightly. What reason we did that is to, in overdrive, we have, there's lots of turning, it's a racetrack basically, there's chaos. And we just wanted to make sure the ball did not follow the robot at all. What will happen next is when we fire it, the forks have to move out of the way, because otherwise the ball is going to hit the forks, because obviously there's a huge piece of fork in the way. So we have to move the forks out of the way. Now once the forks are clear of the ball's trajectory, we'll launch the ball by means of turning off the electromagnetic clutches. I'm not sure if I can. I'm not sure if I should say electromagnetic clutches, as they're in the gray area in the first rules, but they pass inspection. We're not cheating at all. So I think that's it. Let's go fire a ball, shall we? 3, 2, 1, fire! So you can see, I can't exactly replay that in slow motion. If I can, you'll see that in the video on YouTube. If I can't, you'll have to play back YouTube player a bit slower. But as you can see, the forks moved out of the way. This is called a pre-launch position. It's a bit higher than settling position. Right here, it ignores the buttons, because I don't care about the buttons. And once it's here, it releases the launcher. And then, after that, the forks can be moved by user control. That's pretty much the fork system, and the launcher system, I guess. This is Longshot from Team 1261, 2008, for the Underdry First Robotics Competition. If you have any other questions, just comment on the video, or go to our website at prhsrobotics.com. No spaces, no hyphenates. The only thing, just prhsrobotics.com. Thank you.